In the summer of 2021, inside a factory in Fremont, California, Tesla handed over a small batch of cars to their first owners. Nothing about the delivery event looked like it would rewrite the future of the auto industry. But bolted underneath those cars was a piece of engineering that most people in the room did not fully understand yet, and most people watching from home still don't. It was a motor. Just a motor. And yet that motor may be one of the clearest reasons Tesla stopped being just an early leader in electric vehicles and started becoming something the rest of the industry still hasn't figured out how to compete with. It may be the reason the race, as most people originally understood it, isn't shaping up the way anyone expected. Think about how differently this story could have gone. A century of automotive history had already taught every engineer in the industry where the ceiling on electric motor performance sat. Spin a rotor too fast, and it tears itself apart from the inside. So you accept the compromise and move on. That's not laziness. It's just good engineering discipline, respecting a physical limit that had held for generations. Tesla's decision to attack that limit directly instead of designing around it is the kind of choice that looks obvious in hindsight and looks reckless beforehand. And it's worth sitting with that for a second, because most of what follows in this story traces back to that one decision. For years, the story of electric vehicles was framed as a fair fight that Tesla was destined to lose eventually. Tesla got there first, sure. It proved that electric cars could be desirable instead of just responsible. But the assumption baked into almost every analyst report and every car magazine cover story was that the giants would catch up. Ford had 100 years of manufacturing muscle. General Motors had the balance sheet to absorb losses for a decade if it had to. Volkswagen had the global scale and the political will in Europe to force the transition. And a wave of hungry startups, Rivian, Lucid, and others, were supposed to out-engineer Tesla on pure talent. Competition would intensify, prices would fall, and eventually Tesla would just be one strong player in a crowded field. That was the plan. For a while, it even looked like it was happening. Then people started paying attention to what was spinning inside Tesla's most expensive car. Electric motors are not new. The basic idea has existed for more than a century. Pass current through a coil, generate a magnetic field. Use that field to produce rotation. It's simple in concept and brutally difficult in the details. One detail matters more than almost any other. The faster a motor spins, the more power it can squeeze out of the same size and weight. That matters enormously in a car, because every extra pound of motor is a pound the battery has to drag around, a pound that has to be hauled up a hill and stopped at a red light. Lighter is better, and speed is one of the cheapest ways to get more power without adding weight. The catch is that spinning something fast enough to unlock that extra power creates enormous centrifugal force on the rotor, the spinning part of the motor packed with magnets. Push a rotor past its limit, and it doesn't just wear out, it tears itself apart. For decades, this was simply accepted as a hard ceiling. Engineers designed around it instead of solving it, choosing moderate rotational speeds and living with the compromise between power and weight. Tesla's answer was to wrap the rotor in a sleeve of carbon fiber, wound under extremely high tension. Carbon fiber is pound for pound one of the strongest materials available, and wrapped tightly enough around a spinning rotor, it acts like a compression band, holding everything together against forces that would otherwise fling it apart. The idea of reinforcing a rotor this way wasn't invented by Tesla. Aerospace and specialized industrial motors had experimented with similar reinforcement for years. What Tesla did was make it work in a car at car prices, built on a production line fast enough to put one in every vehicle rolling off the assembly line. That required building manufacturing equipment that didn't exist before, machinery capable of winding carbon fiber around a copper rotor with the precision to keep the two materials locked together even as they expand and contract at completely different rates in the cold. Solving that problem is the unglamorous part of the story. And it's also the part that actually matters, because it's the part competitors can't simply copy from a diagram. The payoff showed up almost immediately in the Model S Plaid. Tesla's own claims put the car at under 2 seconds to 60 miles per hour and under 9.5 seconds in the quarter mile, numbers that would be shocking in a stripped-down drag racing special, let alone a full-size luxury sedan with leather seats, a premium stereo, and room for a family of 5. It could out-accelerate cars costing several times as much, cars built by companies that have spent decades doing nothing but chase speed. And it did this while still delivering hundreds of miles of range on a single charge, a combination that the industry had treated as a contradiction for years. You could build something fast, or you could build something efficient. Tesla's carbon-wrapped rotor blurred that line in a way nobody else had managed to put into a showroom car. But here's the part that most coverage of the motor completely misses. The motor by itself is not really the advantage. The advantage is what the motor represents. Tesla's obsession with designing things so they can be manufactured cheaply and at enormous scale. Reports on Tesla's manufacturing strategy have pointed to the company chasing drive unit costs, meaning the motor, the inverter, and the gearbox together, that undercut what legacy automakers are able to achieve by a wide margin, in part by working to reduce dependence on expensive, supply-constrained materials like rare earth elements and premium power electronics. Whether or not Tesla hits its most aggressive internal cost targets exactly, the direction is unmistakable. Every part is designed from day one with the question of how it gets built at volume, not just how it performs on a test bench. That is a very different philosophy from an industry that has spent a century optimizing internal combustion manufacturing and is now trying to bolt electrification onto it. You can see the consequences of that gap by looking at what has happened to the companies that were supposed to be closing it. Ford's Mustang Mach-E and F-150 Lightning were genuinely well received. They are competent, attractive vehicles from a serious manufacturer. And Ford's electric vehicle division has reported billions of dollars in losses, subsidized by profits from the gasoline trucks and SUVs that electrification is ultimately supposed to replace. That is not a stable long-term strategy. It's a company buying time. General Motors has poured resources into its Ultium platform as its answer to Tesla, but sales volumes have lagged expectations, and the software experience tied to those vehicles has drawn persistent criticism. Toyota, the largest automaker in the world by volume, spent years betting on hybrids and hydrogen instead of committing fully to battery electric vehicles. And its first dedicated EV, the BZ4X, launched to mixed reviews and was even recalled over a wheel detachment issue. The world's biggest carmaker found itself playing catch-up in the technology, increasingly defining the industry's future. Volkswagen committed tens of billions of euros to its ID lineup and has had real success in Europe, aided by a strong home market and generous incentives. But its in-house software efforts have been plagued by delays and leadership turnover, and the brand has struggled to gain real traction in the United States and China, the two largest EV markets on Earth. It's tempting to write these struggles off as ordinary growing pains, the kind every new technology goes through before it matures. But that framing misses something important. These are not scrappy newcomers fumbling their way through a first product. These are companies with a century of manufacturing experience between them, deep pockets, established dealer networks, and years of advance warning that electrification was coming. They had every structural advantage on paper, and they are still losing money on nearly every electric vehicle they build. That's not a sign of an industry catching up. That's a sign of just how deep Tesla's manufacturing lead actually runs. Deep enough that decades of institutional experience building gasoline cars hasn't translated into a shortcut for building profitable electric ones. The startups tell a different but related story. Lucid builds what might be the single most efficient electric vehicle on the market today, engineered in part by former Tesla employees who understand this technology at a deep level. And Lucid has burned through enormous amounts of cash producing relatively low volumes at high cost, kept alive largely by backing from Saudi Arabia's sovereign wealth fund. Rivian's electric trucks generated real enthusiasm, and Rivian secured a major investment from Amazon. And the company has continued to lose money on every vehicle it builds because its manufacturing costs sit well above what customers are willing to pay. Both companies have proven they can design compelling electric vehicles. Neither has proven, at least not yet, that it can build them profitably at real scale. Tesla proved both years ago. The one company that presents a genuinely different kind of threat isn't American or European at all. It's BYD, the Chinese manufacturer that has become the world's largest producer of electric vehicles by volume. In some quarters, even outselling Tesla, depending on how plug-in hybrids are counted. BYD has achieved a level of low-cost, high-volume manufacturing competence that no Western automaker has matched. But it competes in a different lane, focused on budget and mid-range vehicles for mass-market buyers, largely in China and other developing markets, while Tesla sits at the premium end. Tariffs effectively block BYD from the profitable American market, and regulators in Europe have opened investigations into Chinese EV subsidies, which complicates BYD's path to becoming a truly global brand the way Tesla already is, with factories now running on 3 separate continents. That global manufacturing footprint is itself a form of strategic infrastructure that took Tesla more than a decade and tens of billions of dollars to build. And it isn't the only advantage compounding quietly in the background. Every Tesla on the road functions as a rolling data collection device, its cameras and sensors continuously recording the driving environment and feeding that information back to train the neural networks behind the company's autonomous driving efforts. More cars on the road generates more data trains better algorithms make a more compelling product, and a more compelling product sells more cars. Traditional automakers have sold vastly more vehicles than Tesla across their long histories. But those vehicles were never built to learn from every mile driven. That distributed fleet of constantly improving cars is an advantage that shows up nowhere in a spec sheet or a quarterly earnings report. And it may ultimately matter more than any single piece of motor engineering. Then there's the battery. Tesla spent years relying on Panasonic to supply cells while it learned the manufacturing side of the business, and has since been developing its own 4680 cell, a larger format design meant to simplify production and improve thermal performance, using a dry electrode coating process that could meaningfully cut both cost and environmental impact if Tesla manages to perfect it at scale. That program has run behind its original timeline, because scaling new battery chemistry and format is genuinely difficult. But the direction of travel is clear. An automaker building battery cells specifically for its own vehicles, inside its own factories, rather than buying a supplier's off-the-shelf product the way every competitor does. The same philosophy runs through Tesla's approach to chips, seats, infotainment, and power electronics, all designed in-house. When the global semiconductor shortage hit the entire auto industry in 2021 and 2022, Tesla adapted its own software and hardware fast enough to keep production lines running while competitors were forced to idle factories, an agility that comes directly from actually owning the design of the systems being disrupted. There's also a layer to this that goes beyond cars entirely. Tesla has been building its own specialized computing hardware aimed at training neural networks on the enormous volumes of video data its fleet generates, on the theory that renting time on general-purpose cloud servers isn't efficient enough for a workload this specific. The same underlying approach, learning from huge amounts of real-world sensor data, is showing up in Tesla's push into humanoid robotics with its Optimus project, and in the automation running through its own factories. Whether or not every one of those bets pays off on the timeline Musk has promised, and Musk has a well-documented habit of announcing timelines that slip, the pattern is consistent. Tesla keeps treating itself less like a company that only builds cars and more like a company that builds cars, batteries, chips, charging networks, robots, and the software to tie all of it together under one roof. That's an unusual structure in an industry where most manufacturers have spent decades getting comfortable outsourcing exactly those pieces to specialized suppliers. Perhaps the clearest example of how Tesla turned an expensive bet into a weapon is the supercharger network. When Tesla started building charging stations back in 2012, it looked like an odd distraction for a car company to fund. Over a decade and hundreds of millions of dollars later, it became the most reliable and extensive fast-charging network in North America, and one so far ahead of the competition that Ford, General Motors, Rivian, and other major automakers have agreed to adopt Tesla's charging connector standard so their own customers can plug into Tesla's network. That is an extraordinary concession in a competitive industry. Rival automakers now depend on infrastructure built by the company they're trying to beat, generating usage revenue and charging data that flows straight back to Tesla. It's worth pausing on just how unusual that concession really is. Automakers do not typically hand infrastructure control to a direct competitor. Ford, GM, and Rivian didn't adopt Tesla's plug because they wanted to. They adopted it because their own customers were telling them, loudly, that range anxiety and unreliable public charging were costing them sales, and Tesla's network was simply the one drivers trusted. That's not a marketing win. That's years of unglamorous, expensive infrastructure work quietly turning into leverage over an entire industry. None of this means the picture is simple or that Tesla's position is unshakable. Tesla itself has faced real headwinds recently, including softer vehicle deliveries and declining year-over-year profit in parts of its core car business, alongside intensifying competition from BYD and a wave of Chinese manufacturers. Elon Musk has increasingly pointed to autonomy, robotics, and energy storage as the next chapters of Tesla's growth rather than simply selling more cars. So this isn't a story about Tesla being invincible. It's a story about why a single carbon-wrapped motor, first shown off in 2021, still matters years later, not because the motor itself was the finish line, but because it was an early, visible symbol of a much bigger pattern. Tesla builds problems it decides to solve rather than compromises it decides to accept, and it builds the manufacturing capability to make that solution cheap enough to put in every car it makes. Matching that requires more than matching one motor, or one battery, or one software feature. It requires matching an entire integrated system of technology, manufacturing discipline, charging infrastructure, and real-world data, all reinforcing each other at once. So far, no single competitor, not the century-old giants, not the well-funded startups, not even BYD, has managed to replicate that whole system rather than just one piece of it. Whether that gap keeps widening or finally starts to close is genuinely one of the more interesting open questions in the entire auto industry right now, and it's worth watching closely, because the answer is going to shape which companies are still building cars a decade from now.